Imagine a time over 600 million years ago, the late Precambrian period, when the first multicellular organisms began to emerge. This was a time of profound biological innovation, a time when life was just starting to experiment with more complex forms. Among these early life forms, some were likely the precursors to a group of animals we know today as cnidarians, a phylum that includes jellyfish. These early cnidarians were simple, soft-bodied creatures, vastly different from the diverse and often intricate jellyfish we observe in our oceans today. Due to their soft-bodied nature, these organisms rarely left behind fossils, making it challenging for scientists to piece together their early evolutionary history. However, through careful study and inference, it's believed that these rudimentary life forms laid the groundwork for the evolution of more complex marine creatures. These simple creatures set the stage for the evolution of more complex forms of life, including the ancestors of today's jellyfish. Fast forward to the Cambrian period, where life truly began to take off. The world was a different place then, yet some things remained the same. The ocean, teeming with life, was home to creatures that would lay the foundations for the jellyfish we know today. Fossil evidence from this era, around 541 to 485 million years ago, suggests the presence of early cnidarians, the group of animals that jellyfish belonged to. These creatures were simpler, but in their simplicity, they held the blueprints for future evolution. They possessed radial symmetry, a design where body parts radiate out from a central point, much like the spokes of a wheel. This layout is still seen in jellyfish today. Additionally, they had tentacle-like structures, precursors to the stinging tentacles of modern jellyfish. These early cnidarians were the pioneers of the jellyfish lineage. Over hundreds of millions of years from the Ordovician to the Cretaceous period, jellyfish-like organisms continued to evolve and diversify. From the murky depths of the early oceans, these primitive cnidarians adapted to their surroundings, braving the test of time and evolution. During the Ordovician and Silurian periods, spanning from 485 to 419 million years ago, these jellyfish-like creatures continued to evolve, diversifying in form and function. They thrived in the marine environments, their radial symmetry and tentacle-like appendages becoming more refined and versatile. As we move to the Devonian period, which lasted between 419 to 359 million years ago, the diversification of marine life, including cnidarians, was even more pronounced. Fossils resembling ancient forms of jellyfish have been found, providing us with a glimpse into the ancient oceans and their inhabitants. The journey continued through the Carboniferous to Permian periods, from 359 to 251 million years ago. The cnidarians, ever resilient, continued to evolve. Some forms adapted to different marine environments, showcasing the versatility and adaptability that has become characteristic of this phylum. From the Triassic to Jurassic periods, 251 to 145 million years ago, cnidarians continued to evolve, adapting to changing environmental conditions. Their resilience and adaptability allowed them to survive and thrive in these changing ecosystems. The Cretaceous period, from 145 to 66 million years ago, saw the radiation of diverse marine life. Various forms of cnidarians, including jellyfish, were present during this period, showcasing the vast diversity within this group. Through constant adaptation and diversification, jellyfish found their niche in the vast marine ecosystem. Their evolutionary journey, spanning hundreds of millions of years, is a testament to their resilience and adaptability. From primitive multicellular organisms to the fascinating creatures we know today, the journey of the jellyfish is a story of survival, adaptation, and evolution. The Cenozoic era, starting 66 million years ago, ushered in the age of the modern jellyfish. From this point in history, the jellyfish lineage continued to evolve and diversify, adapting to the changing marine environments and conditions. Their evolution was a testament to their resilience and adaptability, traits that have ensured their survival for hundreds of millions of years. The Cenozoic era marked a significant period in the evolutionary history of the jellyfish. Fossil evidence from this era reveals the existence of various jellyfish species that closely resemble the ones we see today. These fossils tell us a fascinating story of survival and adaptation, providing a glimpse into the ancient world these creatures once inhabited. During this era, jellyfish continued to diversify into different classes such as Scyphozoa, Hydrozoa, Cubozoa, and Staurozoa. Each of these classes represents a unique evolutionary path, with different species developing distinct characteristics to survive in their specific marine environments. Among these modern species, one stands out for its unique life cycle characteristics, the immortal jellyfish Turritopsis dohrnii. This extraordinary creature has the ability to revert its cells back to their earliest form and grow anew, effectively making it immortal. It's a fascinating example of the incredible adaptability and resilience of the jellyfish lineage, yet it's important to remember that despite their long evolutionary history, there's still so much we don't know about these creatures. The detailed history of individual jellyfish species remains a tantalizing mystery, a subject of ongoing research. Each new discovery adds a piece to the puzzle, helping us to better understand these fascinating creatures and their place in our world's history. While the jellyfish lineage is ancient, the detailed history of individual species is still a subject of ongoing research. And as we continue to delve into the mysteries of these ancient creatures, we can't help but marvel at the intricate story of evolution that has played out in the world's oceans over hundreds of millions of years. The evolutionary history of jellyfish tells a story of survival and adaptation across hundreds of millions of years. From the late Precambrian period where simple multicellular organisms, possibly ancestral to cnidarians, emerged, to the Cambrian period where fossil evidence suggests the presence of early cnidarians. As we journeyed through the Ordovician to Silurian and Devonian periods, we saw the continued evolution and diversification of these mesmerizing marine creatures. The Carboniferous to Permian periods brought further adaptation, with cnidarians becoming more suited to various marine environments. The Triassic to Jurassic periods, Cretaceous period, and the Cenozoic era saw cnidarians continue to evolve and diversify, adapting to changing environmental conditions and the radiation of diverse marine life. In recent evolutionary events, we've seen modern jellyfish species like the immortal jellyfish evolve with unique life cycle characteristics. From simple multicellular organisms to the graceful jellyfish we know today, this journey through time illustrates the fascinating process of evolution.